Okay, so on this problem, it says a hot air balloon is rising vertically at a rate of 3 feet per second, 35 feet from where the balloon started to rise. You're standing holding a rope that is tied to the balloon. It may or may not be wise. So here we are. We're standing right here. I'm a great artiste. Missed my calling. Probably should have been an artist. I'm, of course, joking. So here's a little person. Just a little person. And they're holding the rope right there. Okay. I just had to get a little person there. So find a formula for x squared. X is the diagonal distance from you to the balloon. In terms of y, only y is the height of the balloon. Okay, okay, I can do that. So saying this is x and this is y. So that equation, that's pretty easy, huh? It's just the Pythag, isn't it? Oops. Let me do that. Okay, so that means y squared plus 35 squared is x squared, right? Because it's a squared plus b squared is c squared. Remember, the one that's across from the right angle has to be the c, has to be the one that's alone. All right, so there we go. Yeah, 35 squared plus y squared. That's easy. And then their question is, how fast is the rope passing through your hands when the balloon is 120 feet above the ground? Okay, so that means we need to take the derivative of that equation. So I'm going to take that here. Why don't I put the x squared on the left? Just so it'll look like it does down there. Okay, and then I'm going to take d dt and d dt both sides. This side bring down the 2x dx dt. You got to use the chain rule, right? Because we're doing with respect to time, and none of these letters are t. X and y are not t. So whenever the denominator is different than the function letter, you got to do the chain rule. It's called implicit differentiation. 2 comes down there. So we get 2y, same thing, chain rule dy dt, plus 0. Derivative of a constant number is just 0. It's constant. It's not varying. Its rate of change is nil, 0. All right, so we get to there. Nice thing here is we can just divide through. Come on, I wanted a different color. Thank you. Divide through by 2. And so boom to boom. And so I'll bring that down here. So that's x dx dt is y dy dt. How nice. Okay, what do I know? Um, so now what do I know? Is we can plug some stuff in. The balloon's 120 feet above the ground, so y is 120. So you don't plug in until after the derivative. You remember the steps. Step one, find the rate. So I kind of skip my steps. Find the rate letters. So what are rates? How fast is the rope? So that's dx, dt. They're asking for that. And the other, and it says rising, the balloon is rising vertically. That's dy dt. And that's going up 3 because it's rising. So y is getting longer. The height of the balloon is getting larger height, going up 3 feet every second. So yeah, those are my rate letters. Step two is you write an equation with relating only those letters. And we did that right here. Only X and Y, right? No other letters. You can have numbers, no other letters. Step three, you take the DDT of both sides, and we just did that. Both sides. We just did that right there. And then step four, plug in the numbers. So we don't plug in the numbers till after the derivative, because you plug in a number uh, early, it's going to be 0 because the numbers, the derivative is 0. All right, so unless they're a number that's not changing, like the 35, indeed, that's how far we are from the bottom of the balloon. That's not changing, so that does go to 0. That's appropriate. But the other ones, like the 120, can't plug that in before the derivative because that's changing. 120 is growing, right? So that's y. I'm going to plug in that y is 120. Okay. dy dt is what? No, is 3. Yeah, so that's 3 right there. Put in 3. Yeah, dy dt is 3. Okay. Dx dt is what we're looking for. And then what is x? Do we know x? How are we going to get x? Well, you see, again, we got a right triangle here, right? So we can just go, oh, okay, 120 squared plus 35 squared is x squared. So let's root it. So that's x. X is the root of 120 squared is 35. So there's x. All right, got to solve for dx dt. So then just divide both sides by that square root. Didn't work so well. By that square root, there we go. By that square root. So 120 squared plus 35 squared, bye-bye. 120 squared plus 35 squared. So dx dt, which is what they're asking me for, how fast the rope is passing through our hands, right? And x is the how far the rope is, how that's changing. So we're trying to find, let's do it. Let's go to Desmos. 120 times 3 over. Clear this out. Give me a fraction. 120 times 3 over the square root of something or other. What was it? 120 squared plus 35 squared. 120 and 35. 120 and 35. Get 2.88. 2.88. Oops. 2.88. Yeah, there it is. That's how fast that rope's going through our hands. 2.88 feet of rope per second. Give us a rug burn or whatever, burn our hands. There we go.